Okay, so today now we continue with the formal method. So today we will discuss the JUD specification language. Okay, so in our previous lectures, so we have already discussed about axiomatic specification, algebraic specification, right? And then now today we'll discuss about JUD specification language. Okay, so I told you before also JUD specification language usually used to specify any sequential process. Okay, sequential system, right? So it is a model based system. It's a model based specification technique. Now I start with one example. So because we try to specify JUD specification, we try to apply this JUD specification in a language to develop specification for a sort of problem, right? So we start with an example. Here is a block handler, right? So the block handler actually is a system, part of operating system. Okay, we take this example. So usually what happens, so we create number of files, right? We create number of files, we delete number of files. Whenever you create or you remove certain number of files, actually these files actually take certain number of blocks of memory, right? So now, like, let's say if you created a file, so that file may take or require 3 blocks. Okay, so now you have certain number of finite number of blocks. Okay, and these files actually files will be allotted certain number of blocks when they are created. Okay, and these blocks will be I mean deallocated when the file is deleted. Okay, let's say a file, whenever the file is created, it may takes 3 blocks. Okay, so if the file is deleted, so then that those three blocks will be released, and memory blocks will be released, and that will be considered as unused blocks. Okay, so do understand now, this is what exactly a system part of any operating system, right? A block handler. Now you can see here is a unused used blocks. That means these are the memory blocks currently being used by some of the files. Okay, so now, and the left side you can see unused block. That means these are the memory blocks are not being currently used by any of the files. Okay, and there is a queue block. Okay, there is a queue block. Okay, so now what happens, you see there is a file 1, file 2, and file 3. So these are the 3 files. Okay, now whenever a file, a file is deleted, usually those blocks will be kept in a queue, and those blocks will be ready to those blocks are ready for deletion from its queue. Okay, I mean, you can think of like, okay, so let's say these are the currently being used blocks. Okay, 2, 5, 7, 8, 10, 11, 12. Now there is a file number 1 which is actually currently holding a memory block 2. Okay, and file 2 holds memory blocks 5, 8, 11. Okay, 5, 8, 11. So these are the 3 memory blocks are currently used by file 2, and similarly file 3 also, right? Now what will happen, let's say file 1 is deleted. When the file 1 is deleted, that time what will happen, so the used block will be part of queue. Okay, so now it will be removed from the this queue. Okay, and thereafter it will be added onto the unused blocks. Okay, so there is a set unused block and there is a set used block, right? Now do understand, so now this it maintains a queue. Queue means because it requires some sort of sequence, right? So in a sequence, because file 1 is first deleted, so I mean first you need to free this block number 2. Okay, and thereafter file 2 is deleted. Now that means wanted to delete the file 2, so 5, 8, 11 will be freed later on. Okay, similarly for the file 3, so 7 block will be released later on, right? So it maintains a queue. Okay, and these are the blocks actually ready to go into unused blocks. That is what the idea now. Okay, so now this is a complete requirement of the system, right? Now we'll try to understand what are different aspects it would be. Now keep these things in your mind, right? So here you have a set, here you have a set of blocks, right? Now you have some sets, okay, they are subset of this set, okay? So 2 is a subset of this, 11 is a subset of this, okay? 7 is a subset of this, and now the number of blocks will be the summation of this set and the summation of this set. When you add these two sets, what will happen? That will be going to tell you the number of blocks actually available. That's a finite set of blocks, right? Now, so you can understand. So this is a set and this is a set, okay? Yes. Now I'll talk about here, right? So how, I mean, what sort of mathematical notation really we require, okay, for this? Now state is the collection of free blocks, okay, and the collection of used blocks and the queue of returned blocks, okay? So now you can see, so whenever we talk about a state, because I said you before, it's a state, it's a model based, where usually the state gets changed over time, right? So now you have certain number of operations. When you carry out these operations, it is going to change the state, right? That's the changing of state is something like this, as I said you, right? So here at this point of time, it is the state is this. So you number of blocks, here you have this many number of blocks, and these are the blocks ready for the ready for going to enter into the unused blocks, right? They are ready to get into unused blocks, right, soon. So now this is one state, okay? Now that in the next instance, let's say what happened, so let's say there is a some other file, okay, it's going to be deleted, another file, okay, and that file also holds some sort of some sort of blocks, some blocks, right? Now what will happen at time t0, let's say this is the state, okay, let's say time t1, so and a few other blocks will be removed, okay, that means a few files removed, right, or few files are deleted. As a result, few of these blocks will be removed from the used block and that will be added onto the unused block. So when you remove something and you add something into the unused block, that means there is a change in the state. That is what exactly I explained you before using a producer and consumer example, right? When we started, when we were having discussions on these property oriented and these model oriented specifications, so that time I discussed about this, right? So the same thing here is, okay. So now we'll see. So that is what the state, right? So there are certain data invariant, okay. So the data invariants are something like certain operations, which are exactly there, they are not going to, that means usually they are the operations, okay, so they are the ones, so they never change. These are the operations, they will never change, okay. So they are that particular properties, okay. So now we can see, so that can be expressed in natural language. So what are the operations? So we will discuss. So one operation would be data invariant will be like this. The condition will be like this. Okay, no block will be marked as both unused and used. No block will be marked as both unused and used. Do you understand what I'm trying to say? That means if there is a block number 1, so either that block number should be in the unused part or it should be in the used part. So this block number should not be in both blocks, okay, because so that is what the first condition, okay. So that means the number of blocks are finite number of blocks, and these blocks, so each and every individual block, either it should belong to unused block or it should be belonging to used block, but it should not belong into both, okay. That never happened, right? If it is happening, that means there is a problem, right? If block number is currently used, that means it is unused, okay. So it cannot go into unused block, right? Because it is currently in use. If it is freed, then it will be going into unused block. Okay, so that will be the change of the state. Okay, so that is the way that you need to understand, right? So all the sets of blocks held in the queue will be subset of collection of currently used blocks. Now the second condition here is, as I said now this is one set and this is the other set. Like file number 1, you can see there is a set, there is only one block in the set. For file 2, so the other set is 5, 8, 11, and file 3 the set is 7. Now these are actually sets and they are subset of this used block. Yes or no? Any doubts of our students?
No, sir.
Okay, right. So that now you can see it's a unused is a set. So these are the subsets. Okay, so the sets that are there in the queue, okay, they are actually the subsets of used block set. Okay, that's a one invariant. The other invariant can be no elements of the queue contain same block number. No elements of the queue contain same block number. That means you can see here no element of the queue. So this is the queue. Okay, this is one element of the queue. This is the another element of queue. And file number 3, the set is another element of the queue. Now there are 3 elements here in the queue. Okay, and no element in the queue should have same block number. Can you see any repeated block number? No, you cannot see any repeated block number, right? Understand? So this is another constraint that you have, condition you have, or in data invariant you have. Okay, so this should be maintained always. Now used and unused blocks will be the total collection of blocks, that you understand, right? So the blocks that are there in the used and the blocks that are there in the unused. So if you, that's a total number of blocks actually. Okay, no duplicate block numbers in unused blocks. So no duplicate block numbers in used blocks. So you should not have, you will not be able to see any duplicate numbers in unused blocks or in used blocks. So can you see here 2 repeated anywhere or 7 repeated anywhere in the used blocks? No. So you cannot see, right? Because so that repetition is not allowed. Okay, so it is a single block. Okay, now you see these are the data invariants. Okay, so these are the operations. Okay, now when you over this, now we'll see how we are going to specify this. Okay, so now some operations with this data are, okay, so now we try to find certainly some of these operations, okay, associated with this data invariants. Okay, now the operations here is add, remove, check. Okay, these are some operations, as well as you will have some precondition for add and the precondition for remove. Now we see usually what it all. Okay, so let's say there is an operation called add. Okay, a collection of blocks to end of the queue. Okay, so that means what we are saying here is, okay, so now if you're going through this, okay, so to this diagram, now you can see, so here if this is one set of blocks, okay, if this is one set of blocks, because of the file number 3, because of the file number 3 which is getting deleted, now this set of blocks, now the file number 3 holds the only one block here. Okay, so now this is also one set, right? Now this set of block, okay, now this set of block actually added onto the end of the queue. Okay, this is a queue. Okay, here is a queue. Okay, so now the first element of the queue is the blocks of file number 1. Okay, now the second element of the queue is 5, 8, 11. That's okay. Now third element of the queue here is 7. Okay, okay, so this is what, so what are different operations we really require whenever you wanted to change, if any state change is required, in that case certainly some operation must have some operations are carried out. As a result, the state changes, right? So that means certain number of blocks will be removed and certain number of blocks will be added, okay, to added, right? So now you can see, so what you are trying to do, so one operation you want is whenever a file is deleted, you wanted to add that particular, the blocks that are associated with a file should be added unto the end of the queue. Okay, that is one operation, that is adding certain number of blocks into the end of the queue. Okay, so this is one operation you require. The other operation, can anyone tell me here what would be the other operation required? Just any student here can you tell me what would be the other operation may be required?
Unused to use blocks.
Hmm? Hmm?
When we are creating a new file,
Okay.
then
Okay.
one block should be removed from the unused block queue and added to the used block at the end of the used block queue.
Okay. Okay. That is one. Okay. Fine. So now this way. Now the other thing can be you remove certainly some of these blocks from a queue. No, you have adding certain number of blocks onto a queue. Similarly, you can remove certain number of blocks from a queue. Usually, so you always remove a queue, blocks from the front of the queue, right? From the front of the queue, you try to remove and you try to add from the end of the queue, right? So that could be another operation you can think of, right? So now you can see here we're talking about that. Okay, so a collection of used blocks, okay, from front of the queue and place them in the collection of unused blocks, right? So usually what you try to do here in this case, so the next step you try to remove this block, okay, 2 from the queue, and it will be added onto the unused blocks. That will be the next process, okay, or the next operation. Okay, so you have this another operation here. Okay, now so this is the way that you need to understand, right? And similarly, the other operation could be check whether the queue of blocks empty or not. Okay, so as I said you, so you can have a condition like if the queue empty or not. Okay, you can check that also, right? If the queue is empty, so you can push an element, right? Or you can think of, or you can say if the queue is empty, then you cannot remove any element. Okay, that could be another precondition there. Okay, right? So precondition of add is that blocks to be added must in the collection of used blocks. Okay, so that means the period condition whenever you saying add, okay, so in that case what is saying that the blocks to be added must in the collection of used blocks. Okay, so that means you are saying the something you are adding, the something that you are adding into the queue should be there in the used blocks. Okay, so that means 7. Okay, 7 is there and you wanted to add that. Okay, so that means this 7 is present in the queue. Okay, and that should also be present in the used blocks. Then only if that is there in the used block, then only you can add. Okay, this could be one precondition, right? So you can have several others also, right? Precondition of remove also is that queue must have at least one item in it. Okay, that is what I said you. So whenever you try to remove some operation, a queue, I know whenever you try to remove any of the blocks from the queue, so you need to check that first there should have at least one item. Otherwise, you cannot remove something, right? So this could be another operation. Okay, so now this is the way that you certainly specifying the operations, right? Now we will try to see how Z specification actually actually will be able to specify these all operations and the data invariants or the variables, okay, that you have. Okay, so using any Z specification language. Okay, so given the system here is a block handler. Okay, and we have obtained the data invariants as well as we have seen the operations associated with this particular system. Now we try to see, we try to uh, mathematically specify using Z specification language. Before that, you should know a little bit about how you're going to I mean, what are the notations that will be used so as to develop the Z specification, right? So here you can see, as I told you before also, so here in this case, for our system, we try to use two sets. Okay, what are the two sets? One is used, that means these are the currently used blocks, is a set containing all the currently used blocks, and there is a free, and there is a set called free. Okay, by using free or unused, you can say. Okay, so unused or free, okay, whatever may be. So in that diagram, so we have written unused, right? So unused block and used block. So used block contains set of some blocks, and your free blocks contain these. So these are the blocks are actually free, available for use. Okay, now we create two sets. Okay, and there is a sequence. Okay, sequence will contain sets of blocks that are ready to be released from files that have been deleted. So now, so the whenever we say queue, so it can be a sequence. Okay, now it is a sequence, right? So that means we are we are representing queue with the help of a sequence, not with the help of a set. Okay, so in a set, the order will not matter much. Okay, so instead of, let's say, 13469, you can write 43169 also. So that doesn't make any difference. Okay, so it will say you that these are the elements there in the set, but in a sequence what it says, so order is that very much important, right? Because so if there is a two block, so that means this should be first deleted, okay, from the queue, and 5 8 11, that means this should be deleted next, and 7 should be deleted the last, right? So they maintain a sequence, right? So the queue is implemented using a sequence. So now you see how we trying to specify mathematical, right? So using sets. Okay, so that is what. So all blocks is a set of blocks. So we represent by, so when you say there is a set blocks, which will say that every block, I mean all the blocks. Okay, and all blocks is a set of blocks. So when we say all blocks, so it contains all set of blocks. Okay, all set of blocks. Okay, that is what you need to understand. Okay, so now the two sets here is used and free, and there is a sequence also. Okay, the sequence will contain the sets of blocks, okay, that are ready to be released from files that have been deleted. Okay, now state can be described as, okay, so the in order to describe the state, so usually first we need to mention the invariants. Okay, so now we can see how these can be defined. Okay, so now you see the set used comma free, okay, and then put a colon, and if you write p sort of thing, the symbol, and then blocks, that means what it all says. Can anyone tell me? So before a set, if you write p, okay, what it all means? It's a general notation in sets. Can anyone tell me what is this? If let's say, huh?
Maybe
Yes,
power
yes,
set.
yes. So it's a power set, right? So usually, if there is a set A is equal to 1, 2, 3. So right now the power set of A is usually you write P of A. Okay, so that is going to give you, right. So power set of A is it's a all subsets, right? Subset of blocks, right? So if you have A is equal to 1, 2, 3, the power set will contain something like this. Okay, 5, 1, 2. A set of 1, 2, a set of 2, 3, and then set of 1, 2, 3. So these are the certain subsets, right? So this is what exactly say. So the used and free, they are the power sets of blocks. So as I said, you block contains all the block numbers, right? So used is a power set. Okay, free is a power set. Okay, used comma free, they both are the power sets of blocks. Okay, of the set blocks, right? Now there is a queue. Okay, sequence. Okay, it is a sequence. That is the reason why it is a sequence. SUP. Okay, sequence and then power set of blocks. That means in the sequence also contain the power set. Okay, now you can see, if you want to understand, So better you can understand. Now let's say all set is 1 3 1 2 3 4 5 7 8 till 12. Okay, now used block is a subset, it's a power set. Okay, it's a subset of that. Okay, and unused block. Okay, so used block is a subset of that, right? So now these can be two power set. Okay, now similarly this is also a power set. 2 here is a power set, 5 8 11 is a power set, 7 is also a power set of that. Okay, so this is the way that we define. Okay, so because this is a sequence and it contains the power set. Okay, now you understand. Okay, so this is very much like declaration of program variables, right? So what you try to do, so this shows like a program variables, right? Declaration of program variables, like when you write any program, so if there are two variables x and y and they are of integer type, so what you do, so usually you first define them, right? It is a int x semicolon int y semicolon. That means you are declaring that x is a variable of type integer. So you are saying these are sets, power sets. Okay, so these are the power sets or something like this. Okay, so you are declaring here you have two sets. Okay, here a user set, free set, and there is a sequence block queue. So these are the declarations. Okay, now how we will see in the next slide, then you will be able to understand what it all. Now the data invariants can be written as, okay, so as we have seen, there are certain data invariants. One that invariant is so no two blocks, okay, no two blocks, like no two blocks, okay, used and unused should have should have should have common blocks. Okay, this is the first inner invariant you can see. Okay, the first invariant is what? No block will be marked as both unused and used. Okay, that means so there should not have a block which can be marked as unused as well as used. That means so either it should be in the block, I mean used block, or it should be in the unused block, but it should not be in both. Okay, so that is what we defined, right? Used set intersection, I mean end operation. So you can see, so or free, so it can be an intersection, right? So that is what 5. That means you should not have a same block in both the things. Okay, so they are two disjoint sets. Okay, they are the two disjoint sets. That is what it is going to have. And okay, used blocks union free. If you add so all blocks. So we have defined all blocks. All blocks means it contains all of the blocks. Okay, it's a set of all blocks. Okay, now we have defined before, right? So that should be. And now for all I colon, there is a domain block q. Domain means whatever the element that will be part of block q. Block q mein kya hai? What is that there in the block q? Can anyone tell me? What is that there in the block queue? Anyone?
Set of blocks to be added into the unused block.
Yes. And that is a subset of or the superset of what? Which one?
Used blocks.
Yes, it is a it's a power set of, I mean it's a power set of used blocks. Okay, we already defined, right? Now that's a domain, right? So here you have a type of form of that particular. Okay, so how you are trying to write here? Now we are saying out of this domain, okay, block qi, okay, for all I, that means whatever the block set of block, whatever the set I contained in a block q, okay, should be a subset of used. Okay, that should be a subset of used. Okay, we have seen, right? And okay, now so the other invariant that we are going to write here is, okay, So given this domain block Q, okay, for one element of block Q, I and J, okay, so I and J should not be the same. That means, so that means you are taking two blocks, okay, you are taking two block sets, okay, you are taking two block sets of block Q, okay, I and J, so they should not be same, okay, you are taking two different sets. That means you are saying this, okay, so you are going to take these two, okay, so this is one set, two, okay, is a set, and 5 8 11 is another set, okay, so you are taking two sets I and J in such a way that they are not same. Maybe that means no, by mistake, no, logically it will be fail if you take two sets like 2 and 2, okay, one set 2 and the other set 2, then it won't work. It will work for only two different sets, okay, so that is what it says. Right, so I should not be equal to J. Then what you are saying, the block Qi and intersection block Qj should be phi. Again, that means no two blocks, I mean block set should have a common element again. So as similar to the first data invariant. So that's a first invariant with the all set, all blocks. Now here it is also, the constraint with the block you also similarly, okay, so do understand? Any doubts so far? Any student, any doubts so far here? Right, so can I assume that you understand everything? Ansul, Ansul Jain, are you there?
Yes, sir, I'm here.
Yeah, so is it clear to you?
Yes, sir, it's quite clear. But I'll
Why?
also revise once and will tell you.
No, 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 no. Why? Where you do not understand? I mean, when you say quiet, I mean, you should, what that portion you did not understand. You see, unless and until you people ask me, so I will assume that you understand everything, okay? And which will take more time for you to understand again, okay? So these are the slides I prepared and I have taken from no Pressman, okay? You can go and read. So 575 page number. So there the specification is available in Pressman, so you can go and read. That's fine, okay. But still, you are here online, and if you do not understand, you try to ask me. That is the best way that you require little less reading after that. Otherwise, what will
Sure,
happen?
sir.
Again, you have to read everything. Hmm.
Yes,
So
sir, but I think I understood.
I think you understood. Okay, now. Okay, fine. So now you can see. So first we have seen mathematically we have specified the data invariants. Okay, now we are going to specify the operations, right? So yes,
Hello.
yes, Susri, ask me.
Are all your sir are all your PPT contents are from Pressman book or any other books are also
No, no, no,
included?
no, 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 no. Actually, I have prepared contents from various books. Okay, so various books means the books that are specified in your, syllabus. Okay, so sometimes I take some techniques from the software engineering by Rajim Mal. Some techniques, some slides I prepared, I have taken from Pressman. What would I try to make you understand, right? So the content which will be easy for you, so I have taken in such a way that it will be easy for you to understand, okay. So that is what, and some contents was prepared based on Somerville software engineering by Somerville, okay. So these are the books, right, the standard books. So either you download the soft copies of all of these books, okay, and try to search the content, okay. So usually you will be able to find from some of the books, okay. And sometimes, this is what exactly, right. Is it fine, Susri?
Yes, sir.
Okay.
Yes, sir.
So now we'll see how we are going to specify the operations, right? So the first operation here is first operation to be defined is one that removes an element from the head of the block Q. Okay, so what you are trying to see say, so we try to remove a element from the block Q. Okay, the block Q is there, right? It is a sequence, right? Now the number of block Q, so I mean the number of elements in the block Q should be greater than 0, at least one item in the queue. So that means the condition here is, so number of blocks that will be there in the block queue. Okay, so are the elements, the number of elements that are there in the block queue should be greater than 0. So that can be represented through hash. Okay, okay, so that means I say at least one item that should be there in the queue, then only the operation can be carried out. Okay, the what is that carried out operation? Now the operation will be this. Okay, so as well as you will have some post conditions. Is that the head of the queue? Okay, so the head of the queue must be removed and placed in the collection of free blocks. Okay, and queue adjusts to show the removal. Okay, now we try to see how, because as I told you, so ultimately you need to remove an element from the block queue, that means from the head of the queue. Okay, and it should be added onto the used block, right? It should be to the used block, right? So now you have a used set, you have a used set. Okay, and when you say, and when you and there is a slash. Okay, slash actually going to tell you that it is a difference. Okay, it is a difference. Okay, it is a difference. Okay, difference between two sets. Okay, now you can understand. Let's say there is a set A and there is a set B. Now you so A minus B is what exactly the difference? That means, so it is, so when you find the difference, what it is going to give you? It will give you all the elements of set A. Okay, except the elements of set B are present in A. Okay, except the elements of B which are present in A. Okay, so that means the difference things will be removed and the rest will be left. Okay, so now this is the difference between a set, right? So now what you are saying here is, so when you apply head block Q, that means it is going to tell you that you try to separate, whatever the block element of the block Q that will be removed from used set. Okay, now after removing that element, what it is going to give you? It is going to give you a new set, that is a new used set. That means here the state of the state is changed. Okay, so use from the used set you have removed the head of the block Q. Okay, and what you are going to do now, whatever the free set you have, you going to union with the head block Q. That means the element whatever you removed from the block Q. Okay, so now that will be added onto the free. So that means you going through a union operation. That means you are going to get a free hash. Okay, free hash means it is a new set which is created after adding the block, the the element of the block Q onto the free set. Okay, so that is what. And now, and okay, now block Q, there is a complement. Okay, the block Q complement is equal to tail of block Q. That means, so your tail of block Q, when you write tail before a block Q, okay, the sequence, that means what is going to return? It is going to return again the set of elements of the Q without the without the head of the block Q, because the head of the block Q is removed. Now the block Q contains, so other than the removed element. Okay, the block Q should contain other than that. So tail will return that. Okay, tail will always going to give you the set of elements without the head, because the head is now removed. Okay, in the previous. Now that will be the new Q. Okay, do you understand? So this is what. So you can easily understand this way. Okay, so what you saying here? Now let's say this 2 should be removed. That means this is the head of this set block Q. 2 is the head of the block this. Okay, now what will happen? So this will be, this will be union with this user block. So you have a user block, so that will be union with this. After this union, so you have a set of unused blocks, right? And what will be there in the queue, new queue? So in the new queue, so you will have a tail of queue. That means, so this will be removed and you will have these two elements only in the queue. Okay, so because that is the removed and they will be added onto. Okay, this is the way that you need to understand. Now this is one operation, removal. Similarly, the second operation can be, you wanted to add, right? You wanted to certainly add certain number of blocks, block into the end of the block queue. Okay, that is what you wanted. So now what you are saying is the second operation adds a collection of blocks. Okay, so that's a add block, a block. Okay, to the block queue. So that means there is a block queue. You wanted to add certain number of blocks. Okay, right. The precondition that a block is currently a set of used blocks. Okay, so that means, so whatever the block that you wanted to add, that you wanted to add onto the queue. Okay, so that should be a subset of used. Okay, that should be a subset of used, then only you can add onto the block queue. Okay, otherwise you cannot add onto the block queue. Okay, as I told you before, right? So the a blocks, that means the blocks that will be part of used blocks. Okay, used set, right? That will be part of used sets. That's the reason why that first precondition here is, so a block should be a subset of used. Okay, clear? Now the post condition is that the set of blocks is added to the end of the block queue and set of used and free blocks remains unchanged. Okay, right? Whenever you adding, certainly whenever you are adding some of the blocks onto the block queue. Okay, so you actually adding the blocks into the block queue, but at the same time, there wouldn't be any change in the set of blocks. Okay, the total number of blocks. That means neither it will be reflected in the used block or nor it will be reflected in the free blocks. Okay, free set, because so this is what you can understand, right? So that will be there. So now what you are saying, so the block queue contains, the new block queue contains what? The block queue, existing block queue, plus there is a concatenation operation. Here is the concatenation operation. Okay, and the sequences are represented through, this. Okay, so a blocks is a sequence. Okay, it's a sequence. A blocks is a sequence, right? Your block queue is also a sequence. Now you concatenating two sequences. That means, so you can add this particular add blocks. That means the number of blocks that you wanted to add into block queue should be added at the end only. That means in a sequence only. Okay, so you cannot add this number of blocks in the middle of the block queue or in the head of the block queue. You cannot add. Okay, so that is what the understanding, right? So the concatenation operation here is this arc. Okay, so through this you can understand. So a blocks is a sequence. Okay, and your block queue is also in a sequence, right? Now, so this is what exactly concatenated, right? And so new used block, so used set will not change anything because the same thing will be there, right? And free set is also not going to change because of that. So the same set will be the new set again. Okay, do you understand now? Yes. So any doubts so far, students? Right. So now the Z specification language. So these are the notations we have seen. So these are the notation actually will be used to specify specify all of these the requirements using Z specification. Right. Now we'll see that. So it applies type sets. So that means it uses sets, relations, functions within the context of first order predicate logics. So we'll see that these operations or the functions whatever we have seen, so they can apply the first order predicate, the AND OR operation. That is what you have seen also, right? So you can see here is a AND operation you have seen. So certainly you apply AND operations, right? Now that is what. So you apply some union, and so these are the certainly operations that you can apply, right? Now we'll see that. Okay, so that is what it all uses, right? So Z specifications are organized as a set of schemas. So now here part of Z specification, so it all, all the specifications are, organized as a set of schemas. So what is a schema? So schema is a language structure that introduces variables and specifies the these variables. Okay, so that means it is also a language. Okay, it's just it's a, we can say, it's a structure through which it will be saying that what are different variables and what are the different relationships that exist between these variables are specified. Okay, now a schema describes the stored data that is system accesses and alters. So you understand schema. Usually you probably studied in your database. So usually what is, so it's a kind of, schemas are usually used to, describe how these data are stored and how we can access the data, stored data, and how we can alter this data, right? So that is what exactly a schema, right? So here is also the same thing, so same sort of thing, but in the context of JAD, so this is called as a state, not the schema. Okay, so this is called as a state. Okay, so usually the schema. Okay, so everything will be represented in terms of schema here. Okay, so part of JAD specification language. Now a schema identifies the operations that are applied to change state. Okay, so part of schema, what it will have, what it will identify, it will find that what are the different operations that can be applied onto the variables so that it will change the state. Okay, so like what? So adding, removing, okay, so checking, so these are the various operations. This add, remove, these sort of operations, what it is happening, so it is actually changing the state, right? It is actually changing the state. That means some of these blocks will be removed from one set and it will be added onto other set. That means there is a change in the state, right? So now the relationship that occur within the system, okay, as well as so you try to see how these operations are related to each other in order to execute a behavior, right? So now the schema, let's say there is a schema X is defined by the form like this. Okay, so there is a schema called X. Okay, let's say you have one schema required. Okay, so that will contain certain number of operations, right? So usually the schema you can see in this below form. So you have a declaration first and then you have a predicates. Okay, so declarations are very similar to the program variable declarations. Okay, so here we have seen the declarations. Okay, so the declarations are different used and free sets we have declared, right? First we have declared and then we have given the operations also. The operations in terms of we have seen in terms of union sets and all those things, right? We have implemented. Now here the schema looks like this. So the schema X, so under which you will have certain number of declarations and you have certain number of predicates. Okay, now keep this thing in your mind. Okay, so now these are the symbols will be basically used. Okay, you understand probably. So these are part of any set. So when you write S colon PX, okay, so it all says it's a S is a set of is a set of X. Okay, that means it is a power set. Okay, so S is a set. Okay, set of X. Okay, so that means it's a power set. Okay, and when you say right, small x belongs to capital X, that means the element small x is a member of set S. That means it belongs to the set S. If something not belongs to, okay, so belongs to slash, and there is a subset, you understand, and then S union T, you understand. Union means it contains all of the members of S and T, okay, or both. Okay, so S intersection T means it is all going to give you every member of both S and T. Okay, and S minus T is the difference. That is what we have used in the previous slides, right? So if you wanted to find the difference, and phi is a empty set, okay? And when you write within the curly bracket, if you write only one X, that means it's a singleton set. That means it's only set containing one element, okay? And if this sort of n, it's a natural numbers, okay? And when you write S F, that means it is declared as a finite set, okay? That means it contains finite number of elements in the set, okay? And maximum of S is means it is going to return you, so the maximum of the non-empty set members, okay? Whatever the maximum value that contains is going to. So these are the various usually symbols we use in the sets theory, okay? Similarly, you can see here for some functions, when maybe the partial injection function from x to y can be represented like this: domain of f, that means set of values of x for which f of x is defined, okay? So that means these set of values can be applied to f of x, okay? Similarly, range means the set of values taken by f of x, okay, as x varies over the domain of f, okay? So you understand domain and range, you understand, right? So this way you can represent also certainly, okay? And the predicate logics that we have seen here is p and q. That means here p and q, it is true, both p and q are true, okay? So that means if p is true, q is true, then only the predicate is true. P and q becomes true, right? So p implies q, that you know. It is true if either q is true or p is false, okay? So this way. So no components of the schema S change in an operation, okay? So whenever there is operation, if that operation applied, so if that doesn't give you any changes, so usually you can represent this way, okay? S dash, theta S dash is equal to theta S, okay? Whenever there is no components of the schema get changed because of operation. Okay, so now so we are going to use these all things, right? Part of, right? So now the is part of your as I said you, so how you apply, how you develop. Yes, doubt. Someone asked, wanted to ask. No. Okay, so now the schema is developed like this, okay? Now you can see block handler schema. So as I said you, so it takes the form like this: first declarations and you have predicates, okay? So why it is a predicate? Because there are certain statements added by conjunctions, okay? So and operations, right? Now you can understand, right? So this is what already I have discussed, okay? This is also I have discussed, right? So now, so usually you develop the block handler schema in this way. So first this first block will contain all the declarations and the second part will contain all the operations, okay? So here you have seen one certain number of operation. The operation here is something adding, okay? Now you can think of, in the next slide I can show you, okay? Let's say whenever a schema representing the data invariant, okay, and a state is used in another schema, it is preceded by the delta symbol, right? Let's say this is the operation actually, okay? This is the operation, okay? That will be, so this is the operation that will be actually being used in block handler, okay? So these are the invariants. You have seen data invariants, and these are the declarations, okay, of the block handler. Now this operation, you have seen this operation, okay, like removing an element from the used block, okay, and that will be added onto the free block, okay? That is what you have seen, one operation, right? And this operation is actually a part of block handler. Whenever this operation is a part of block handler, this is also a schema, okay? So this is a remove block schema, okay? So this is a remove block schema, so for which this operation is actually part of the block handler. Whenever you wanted to say like this operation is part of a block handler, so then you precede a delta symbol, okay? So this is the way that you can have multiple number of schemes for your problem, right? So now similarly the add block is another schema. Okay, so add block here is another schema, right? Now the same thing you can see here. Okay, we have already discussed about this part, this operation, right? So first the add block should be a subset of used, okay, and then it should be concatenated with the block queue. Okay, so where your used and free will not change because it is just added onto the end of the queue, right?
Yeah.
Yes, Rajat, you
Not
are asking
getting the
something. Rajat, you are asking something. Okay, so Rajat is not asking anything, right? So now you can see. So there is a question mark. Okay, so there is a question mark here, right?
by mistake actually, sir. I unmuted. I'm sorry.
Oh, okay, fine. So now you see there is a question mark. Okay, that's only only extra thing. No, here you can see now. So as I told you, so whenever you have some sort of block, A blocks means these are the blocks that you wanted to add. It's a sequence again. I told you, right? But this sequence is actually is a input parameter. Okay, it's not actually belonging to the state of, it is not belonging to the state of the scheme. Okay, I mean state of the system. Okay, because A blocks is not going to change the state. Okay, A blocks is a extra, you can think of a auxiliary array. Okay, it's not a part of that array. Okay, so it's an auxiliary array. You can think of, right, this is an input, it is an input parameter, right? So now these blocks are not going to change the state because these number of blocks exactly only concatenated into the block queue, and it is a subset of, a subset of used set. Okay, subset of used set. Okay, so when you add this thing into the queue, so you are actually not going to change the state of the system. The state of the system is the same thing, right? So that is what exactly we say. Okay, so those parameters which are not part of the state, so they can be indicated with a question mark. Okay, and the delta represents that this is the particular schema which will be used in block handler schema. So you have a block handler schema where the declarations invariants are explained. Okay, now this is the operation actually part of that. So then you should have the delta. Okay, so this is the way that you will be actually going to specify a system, subsystem. Yes, any doubts so far, students?
Hello?
Susri, any doubt? You are going to ask
Yes, sir.
something?
Yes, sir. Sir, can you please describe the delta symbol once again? I couldn't clearly get it.
You see, this I said you, so in part of Z specification, okay, so you can have many schemas. Okay, you can have many schemas. Okay, all these operations, declarations, wherever you require, that can be represented through a particular schema. Okay, now add block is one operation. Okay, so now this, for this operation you have developed one schema. What are the schema here? So it contains a declaration A blocks. Okay, it contains the operation like this. Okay, right? So these are the certain conditions, right? That means, so add block you developed. Okay, now this add block operation is actually belonging to the block handler. Okay, so block handler actually, this is a part of block handler. Okay, so in the very first schema we have seen is a block handler. Okay, this is the block handler schema where what you have data invariants, you have the declarations. Okay, now but part of this we can further write those operations, add, you can mention that, what do you say, add blocks, remove blocks, add, remove, those operations can be written part of this. Okay, but what we did is, because we made this as a main schema. Okay, and then we have developed the other schemas like remove block is one schema, another schema. Okay, but what you are saying is this remove block schema is part of that. That main is going to, let's say you see you have a main program. Okay, so you are going to develop a main program, right? So what in part of main program, what you are going to do? So let's say main program, within that you have, you wanted to go into function 1, 2, 3. Now those functions are defined somewhere else, developed somewhere else. F1 may be separately developed, F2 will be separately developed. Now what you're giving, references, right? So F1 function is part of this main, F2 is part of this main program. Okay, right? So that is what I say. Okay, so whenever you wanted to say that this F1 function belonging to the main function, okay, F2 function belonging to this main function, if you want to represent something, so you need to give a delta, then you people will understand that, okay, this is a schema which will be used part of the block handler schema also. Okay, clear?
Okay, sir. Sir, just to sum up, can we just think of the delta symbol like a scope resolution operator, something like that?
It's not a scope, it is what saying that block handler is here written. Okay, that means the operations that you have remove block is the schema which is a part of block handler. Okay, block handler के अंदर remove block is another schema used. Okay, let's say you
Block
have
handler
a
is something like the main program.
Got it.
main program. Okay, block handler is something like a main program. So within that you called a function f1, you called a function f2, and those function f1 and f2 are separately developed. Okay, now you wanted to tell here you have not developed. Okay, main program you have not developed that f1. Only what you did is you made a call to f1. Okay, f1 you called f1. Okay, and f2 you called, but those f1 and f2 are part of maybe developed separately, maybe that will be in the another program. Okay, so now you just want to tell that this f1 where you developed f1, there you wanted to tell that this f1 is part of actually main function. Okay, the f2 is part of main function. Okay, main function has a name. Okay, you can give some name, right? So it is a reference. Okay, it's just telling that this is part of that. Is it clear?
Yes, sir. Yes, got it.
Yes, yes. So it's a just link. Okay, but so part of your system, there will be many more schemas, and these schemas can be part of a main schema. Okay, so this is the way that you will have to develop. Okay, so now I stop this. Okay, so I stop the recording and I download the